Hello there. Today we'll be doing Leetcode Neetcode number 50 out of 150. That will bring us to 1/3 of all the problems. This is called find minimum in rotated sorted array. It's a little bit similar to search sort rotated sorted array. So we're going to be using some of the same concepts here. In this problem, we don't have a target. We're just trying to find the smallest item. So we can use the same idea as before, where we check the left and the medium. If it is in this particular range, that means it must be to the right, because well, there must be items out there in the world that might be smaller, because we already checked this portion. I mean, this portion, if it was in order, if it was left to right. So if we had our range, so let's just set our left and right pointers to get some idea of what's going on. So left pointer is right pointer, and let's get a set of min num that we found equals to nums of 0. First of all, so while L is less than or equal to R, let's keep going. So we're looking at the entire portion of this array, and what happens is that if they're currently in order, that means nums L is less than nums R. That means we are in order, and that means we can return nums. Min num is equal to min num. And nums of L, that which is the smallest number, and we can break. Otherwise, if let's set m to L plus equals R minus L divided by 2, and set min num to equal to the min of min num, or nums of m. So with that, we can start eliminating this particular portion or this particular portion here. So say our medium point was 5. How do we know if we should eliminate this portion here to find something in here, or should we eliminate this side and check this side? So if nums of L is less than or equal to nums of m, that means we are increasing order from L to m, and that means if we were in the case where L and R, we would have, if we were that was the case, if we were in order, we would have gone the nums L, and we would have broken out a loop. Otherwise, we have not gone out of the loop. We're still in the situation where there could be something bigger on the, there could be something smaller on the right side, or bigger, even bigger on the right side, because we're in this this loopy thing, this rotated section, and we know that it can't be on the left side anymore. So left equals m plus 1. Otherwise, where are we? We're in increasing order from m to r. And we know that everything after m is going to be bigger, and we don't want anything bigger, so we're just going to go for something smaller. When we do that, so basically we basically go left, and now we're here, 1 and 2, and so we take the middle item of that, which is 3 and 4, which is 7. 7 divided by 3 is going to be 7 divided by 2 is going to be 3, because we round down. And so we're here at 1. And at 1, we check ourselves at, well, to forget that, L and R is basically at a junction where we can just find the minimum and get the answer. So anyways, let's run the code. Oh shoot, I forgot to run the return the min num. So at this case, we're going to return the 1 when L and R, we found that section where the minimum number is less than, where it's completely in order. We're just trying to get to this in order section and with the minimum number available. Another way to do this is to find the pivot point. The pivot point is a little bit more difficult to find, but let's do it. So let me reiterate the lesson here. The lesson here is to find this particular point where L is less than R, and that means the L must be the smallest item generally, and we just return nums L. So we are eliminating sections where the L might not be the smallest, and we're looking for the sections where the L can be the smallest. And that's it. So same thing. We're gonna do L and R equals 0. But what we're gonna do here, instead of looking at a for this L and R situation, we're gonna look for a pivot situation. So less than or equal to R, and so minimum is left. Left plus right minus left divided by 2. Okay, here we go. So if m plus 1 is less than the length of nums, and nums of m is greater than nums of m plus 1, return nums m plus 1. So basically, we're looking at that pivot point. Once we have found that pivot point where m is greater than the next item, that means the previous item is greater than the next item, we're gonna return the next item, right? Yeah. So this makes sure that we're in bounds, and this makes sure that that's the case. And so once that is the case, we're good to go. If so, we're trying to make sure we get to that section, that pivot point. And how do we do that? So how we do that is that we look at the midpoint against the last item in our if it is less than, that means we can eliminate it. Eliminate everything that's bigger. So we're eliminating everything that's bigger than the midpoint, and so we're getting smaller items. All the items where m is less than the last point, it has to be. It's just must be a smaller item. Otherwise, if it is greater than the last item, so this m is greater than this last item. Let's say we have 5, right? Let's say we have 5. If it is greater, then left is going to be m plus 1, because we want to eliminate all of those smaller numbers too. Suppose we are at well, at 5, of course, this happens. We found the point. Let's say we're at 4, and so L is gonna just remove all these smaller items, right? And we're trying to find that maximum number as well. So and this side, let's say we found a 1. 1 is less than 2, so R is going to be at 5. Because we don't want the smallest items, and we also don't want, we just trying to remove all the small items possible. Yeah, and that's exactly what we're doing. And now we can return. Well, I think that's it. That's actually the code, because yeah, well. Oh, whoops. I think we missed something. Let's see. I don't know what I'm missing, actually. Yeah, I'm not sure, because do we return nums of m? Why would we return nums of m? Yeah, so it looks like nums m goes to the last number available, and yeah, so that means r just keeps pushing back, and l and r is at the starting point, and that's how we get m. So I don't think this method is very useful in an interview, because we just can't wrap our heads around it and even come up with a solution. This particular pattern here instead, I think, it makes much more sense because we are familiar with the pattern and we can apply it. And so I think this particular pattern, even though it's slower, it's still log of m. This particular pattern here, instead to find the pivot point, is to it takes a lot of thinking to eliminate these items, and it's all about elimination. But I think going with this one makes a little bit more sense. Well, anyways, if you have any questions, please comment below. If you enjoyed the video, like and subscribe. And if you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.